So we've been given this equation. They want us to solve this pair of simultaneous equation given that at t equals to 0, x equals to 0, and y also equals to 0. First of all, we need to know that when you've been given equations like this, that dot y, then we have dot x, then this is dot y is the same as dy dt, and then dot x is the same as dx dt. Sometimes you can be given something like this, for example y double dot, this is the same as d2y dt squared. And if it's given, for example, y triple dot, then this is the same as d3y dt cubed, etc., etc. Therefore, for us to solve this simultaneous equation, first of all, we need to change the mean to, we need to get the Laplace transform of this equation. Now, Laplace transform of y dot, this equals to s y bar minus y naught. Laplace transform of x, this equals to x bar. Then Laplace transform of exponent t, this equals to 1 over s minus 1. And then we also get the Laplace transform of the second equation, the Laplace transform of x dot, this equals to s x bar minus x naught. Laplace transform of y, this equals to y bar. And then lastly, Laplace transform of exponent minus t, this equals to 1 over s plus 1. Now we can now rewrite the equations in Laplace transform. So we have y dot, we replace with the sy bar minus y naught. So here we have sy bar minus y naught. Then x, the Laplace transform of x is x bar, so minus x bar equals to the Laplace transform of exponent t is 1 over s minus 1. Then the second equation, the Laplace transform of x dot is sx bar minus x naught. Then the Laplace transform of y is y bar, so plus y bar equals to the Laplace transform of exponent minus t is 1 over s plus 1. So once we get the Laplace transform of the equations, we now insert in the initial conditions. Remember, we had been told that at t equals to 0, x equals to 0, y equals to 0. So from the two equations, y naught is 0 and x naught is also 0. Therefore, the two equation becomes sy bar minus x bar, because this is 0, equals to 1 over s minus 1. And then this equation becomes sx bar minus, so this is 0, so it will be plus y bar equals to 1 all over s plus 1. Now at this point now we need to solve the two equations. By we either eliminate y bar or eliminate x bar and then solve the two equations. Now if I want to eliminate y bar here, you realize that here is sy bar minus x bar. Then so if I want to make this one the same as this, then I'll multiply through the second equation. Here this is the first equation, so you multiply through the second equation by s, so that this one is the same as this one, then we can subtract. So let's multiply through the second equation by s, so that we have s squared x bar plus sy bar equals, now it will be s over s plus 1. Now as we multiply through this equation by s, then this is what we have. Then we shall take this equation minus the first equation. In that, now here we have s squared x bar plus sy bar, then minus, we now subtract this. We subtract this, which is sy bar minus x bar equals to, now we shall take this on this side, s over s plus 1 minus, we subtract this, 1 all over s minus 1. Now let us open the bracket here. So we have s squared x bar plus sy bar minus sy bar minus and minus plus xy bar equals to, now when we subtract here, LCM is s plus 1 into s minus 1. S plus 1 goes how many times? It goes there, s minus 1 times s. So s into s minus 1 minus 1 into s minus 1 goes how many times? S plus 1. So s plus 1. Now on this side, this is positive, this is negative, so they cancel out. So we remain with the s squared x bar plus x bar equals to, now when you open up the bracket, we have s squared minus s minus 1 over s plus 1 s minus 1. So this will factorize out x by here, so that we have s squared plus 1 x bar equals to, now here you have s squared minus 2s minus 1 all over s plus 1 s minus 1. Now if we want to get the x bar, we divide through by s squared plus 1. Therefore x bar equals to s squared minus 2s minus 1 over s plus 1 s minus 1, then s squared plus 1, like that. Now at this point now, we get the partial fraction of this expression. So how do we get the partial fraction for this expression, which I say that s squared minus 2s minus 1 over s plus 1 s minus 1 s squared plus 1. This equals to, now remember, every single linear factor in the denominator will give rise to a single partial fraction. Therefore, here should have a over s plus 1 plus b over s minus 1, then plus. Now, s squared plus 1 cannot be factorized into linear factors, so this factor will give a partial fraction of this form: cs plus d over s squared plus 1. Therefore, we can now move on to calculate the value of a, b, c, and d. Now we shall multiply both sides by the original denominator. We shall take this, multiply on this side, and multiply also on this side. So when you multiply on this side, it will cancel, so that this side will remain with the s squared minus 2s minus 1 equals to, now on this side we multiply by, you take this times a here, so s plus 1 will cancel with s plus 1, and then we remain with a into s minus 1 s squared plus 1, then plus b into, now when you take this, the original denominator, and multiply by b here, this s minus 1 will cancel with this s minus 1, and then we remain with the 2. We remain with s plus 1 and then s squared plus 1. This multiplication, then plus. Here we have cs plus d. So when we multiply this with the cs plus d, s squared plus 1 will cancel with this s squared plus 1, and then we remain with this. So here we have s plus 1 s minus 1. Can now open up the brackets. So we have this, which is s squared minus 2s minus 1 now equals to, now here we open up the bracket, we have a into s times s squared, we get s cubed, s times 1 we have plus s, negative 1 times s squared, we get negative s squared, negative 1 times 1 we have minus 1, close the bracket, plus b into s times s squared, we have s cubed, s times 1 plus s, 1 times s squared, we have plus s squared, 1 times 1 plus 1, close the bracket. Then this is a difference of two squares. When you multiply s plus 1 into s minus 1, you get s squared minus 1. Therefore here we shall have cs times s, we get plus cs squared Then we have CS times negative 1, we have minus CS. Then we have D times A squared, we have plus D A squared. And then we have D times negative 1, have minus D. We have minus D. So we can open up the bracket here. So we have A squared minus 2S minus 1 equals 2. Now here we have A times S cubed, we have A S cubed. Then here we have plus AS. Then we have minus AS squared minus A. Then plus BS cubed. Then plus BS squared plus B. Then plus CS squared minus CS plus DS squared minus D. So we group like terms. Those that have S cubed, we put them together. Those that have S squared, so this will be equal to, now I'll have A, this one, plus B, and then of course we have C. Where is the value of C? Let us see how we are multiplying here. So you can see that here C, when you multiply here, this is C cubed, CS times A squared. This is C cubed, because we have CS times A squared. This will be C cubed. So this is C cubed. So we have plus C, then S cubed, then plus, we now go for A squared. We can start with the positive, B, then minus A, and then we have plus D, then we have A squared. Then those that have S can start with the plus B, which is this one, then plus A, which is this one, then minus C, that. Then we remain the constant terms. We have plus B, minus A, minus D. That is it. So at this point now we equate the coefficients of S. So we shall start with S, the coefficients of S cubed. So here we have A plus B plus C. On this side we don't have S cubed, so it will be equal to 0. Equation 1. Then we equate the coefficients of S squared. On this side we have B minus A plus D equals to the coefficients of S squared. On this side we have 1. Equation 2. Then coefficients of S, on this side we have this one. So we have B plus A minus equals to S. On this side we have minus 2. Equation 3. Then we equate the constant terms. We have b minus a minus d equals to -1. Call it equation 4. So we can now solve the 4 equations to get the values of the constant. Now if I can make b the subject in the 4th equation, in that I'll say that b equals to a and d crosses equal sign, it becomes positive, so it will be a plus d minus 1. So that's the value of d. Therefore, where there is b in the remaining equation, I substitute with this. So if I start from the 3rd equation, I'll have a plus d minus 1, then plus a minus c equals to -2. This and this are 2a plus d minus c equals to, when 1 crosses to the other side, it becomes positive. -2 plus 1 will remain with -2. Call this equation x. Then I substitute p in the 2nd equation. I have a plus d minus 1 minus a plus d equals to 1. A and a will cancel. So I have d plus d, I have 2d equals to -1 crosses to the other side, it becomes what? Positive. So which is now 2. 2d equals to 2. Therefore, d equals to 2 over 2, which equals to 1. D equals to 1. That's fine. We have the value of d. Then we substitute this b in the 1st equation. So we have a plus b is a plus d minus 1, then plus c equals to 0. This is 2a. Now d is 1 plus 1 minus 1 plus c equals to 0. So here we have 1 minus 1, it cancels. So we have 2a equals to minus c. 2a equals to minus c. You can call this one equation y. So we can solve the 2 equations. That 2a equals to minus c, and here we have 2a. So we can replace this 2a by minus c. So we have minus c, which is this one, plus d minus c equals to -1. So here we have minus 2c, but remember d is 1 plus 1 equals to -1. So -2c equals to, when 1 crosses equal sign, it becomes minus, so it will be -2. Therefore, c equals to -2 over -2, which equals to 1. So c also equals to 1. Then we have solved the 2 equations. From here you substitute the value of c, because -c equals to 2a. So this is now -c plus d minus c, which is this one, minus c plus d minus c. So you have minus 2c plus 1 equals that. 1 crosses equal sign, becomes negative. So c equals that. So if c equals to 1, what will be the value of 2a? Because now 2a equals to -1, a equals to -1/2. So yeah, a equals negative a half. Now we want to get the value of b. Now remember that b is given by this, so we can say that now b equals to, now a is negative a half, d is 1 plus 1, then minus 1, is equals negative a half. So what we are saying is that a equals to negative a half, b equals negative a half, d equals to 1, c equals to 1. And do you remember our equation, which is this one? Therefore x bar equals to, now a is negative a half over s plus 1 minus a half over s minus 1. We are just substituting the constants, then plus, now c is 1, so it will be s over s squared plus 1, then plus 1, d is 1. Now, so this equals to, this is the same as negative a half s plus 1 minus a half s minus 1 plus, we can break this fraction, s over s squared plus 1 over s squared plus 1. This is x bar. Now to get the value of x bar, we get the Laplace inverse on both sides of this equation. So the Laplace inverse of x bar will be equal to the Laplace inverse of negative a half s plus 1 minus a half s minus 1 plus s over s squared plus 1 plus 1 over s squared plus 1. Now the Laplace inverse of x bar will be x, which equals to minus a half the Laplace inverse of 1 all over s plus 1 will be exponent minus t minus a half, this will be exponent t plus the Laplace inverse of s over s squared plus 1, it will be cos t plus the inverse of 1 over s squared plus 1, it will be sine t. Now this is the same as minus a half into exponent minus t plus exponent t plus cos t plus sine t. But you realize that what is this? This is cos t. Therefore, we shall say that x equals to, now it will be minus cos t plus sine t. X will be equal to minus cos t plus sine t. And that is the value of x. Now to get the value of y, you simply go back from where we started. You remember here we at this point when we were eliminating the value of, remember we multiplied through this equation by s to make this equal to that. So if you want now to get the value of y, you now eliminate what? You now eliminate x, you multiply through the first equation by s, and then you work through the way we have done up to the end to get the value of y. Thank you for watching and listening.